Hey there. Welcome back to this video in section 3.9. Now we're going to talk about pages 3 and 4 of the notes. So we're going to look at the derivative of natural log of x. So remember, natural log of x is the same thing as saying log base e of x. Also, if we transform it using this right here, we know it's the same thing as saying x equals e to the y power. Given that x has to be greater than 0, so that we could take the natural log of this. So let's say I differentiate this right here with respect to x. I'll get 1 equals e to the y times dy over dx when I'm using implicit differentiation. So dy over dx is equal to 1 over e to the y power. Or, because x equals e to the y power, just 1 over x, given that x has to be greater than 0. Because again, you can't have e, which is 2.7 something, raised to some power and have it equal a negative number. So x has to be greater than 0. So 1 over x when x is greater than 0. Or 1 over u times du over dx, given that u is greater than 0. If you're taking a natural log of something that's not x, something else, so you have to use the chain rule. So, like this case here, y prime will be 1 over 7x, because that's u right there, times the derivative of u, which is going to be 7. So actually, I'm just getting 1 over x. Again, given that x has to be greater than 0. Or we could look at it this way. Y equals natural log of 7 plus natural log of x using your log properties. Remember, the log of AB is log of A plus log of B, right? That's a log property that we should know. If I took the derivative of that, ln 7 is a constant, that's 0. ln x, now we know is 1 over x. So you still get the same thing. Let's look at the derivative of log base ax. So in this case, y is going to equal, actually before I do that, change the base formula, which is kind of good to know. Or not kind of good, it is good to know. It's the same thing as saying ln x over ln a. So if you have like log base 2 of 8, for example, that's like saying ln 8 over ln 2. Or for that matter, you could say log x over log a if you did like a common log. Or just any base, log base bx or log base ba. So that's change the base formula. Now coming back here, again, we can rewrite log base ax as this, or 1 over ln a, which is a constant, times ln x. So the derivative will be 1 over ln a times 1 over x, given that x is greater than 0. So we can express this more compactly as 1 over x times the natural log of a. Or, if you're not taking log of a simple x, say something else like log of x squared plus 4 or whatever, u times ln a, where a is your base of your log, times du dx, which is again using chain rule, given that your whatever u is has to be greater than 0. So let's look at examples 6 and 7 down below. Y prime will be, well actually before I do y prime, I should probably rewrite this as log base of x and negative 2 power. So now y prime will be 1 over whatever u is, this right here is, we're calling u, x negative 2 times ln 7 times the derivative of x negative 2 is negative 2x negative 3. So y prime, if I do a little bit of a maneuvering, x squared up top, negative 2 right there, x cubed down below, times ln 7, and cross that off. So y prime is simply -2 over x times ln 7. Or in this case here, y prime will be 1 over sine x times natural log of 10, because you have a common log, so it's base 10, times to the inside, which would be cosine x. So my derivative is this, cosine x over sine x times natural log of 10. Finally, we can prove that power rule works for any real power. So xn equals e to the p. If I took natural log of both sides, I would get this. So you have n times natural log of x equals p times natural log of e. Just using our power property. And ln e is just 1, so p equals n times natural log of x. Or now we can say x to the n equals e raised to n times ln x power, because that's what p equals. So we have this right here. And derivative of e to anything is what it is, e ln times ln x. And then if I do the chain rule, change derivative with respect to x of n times ln x. So you have e n times ln x times, now n's a constant, so you just wind up getting that. Well, e to the ln x is the same thing as x to the n power. We're able to make that relationship because we're able to isolate p from this right here, and realizing that x to the n equals e to the p, or x to the n equals e to the n times ln x, so we can replace this with x to the n power times n times 1 over x, which will end up becoming just this. And voila, there's the power rule. The power rule has been proven. So in these examples, like y prime is just root 3 times x root 3 minus 1. Or in this case, y prime is 5 pi plus 2, put them in parentheses, times x to 5 pi plus 1 power, because you can subtract 5 pi plus 2 with 1. So power rule works for any exponent, doesn't matter. As long as it's a constant exponent. So keep that in mind, any real number. Lastly, we'll do example 10, and then we'll pick up example 11 when we meet again as a class. So you have to find at what point is this equation or has a tangent that's perpendicular to this line. So it means that we want our derivative to equal 3, right? Because you want to be perpendicular, you want the negative reciprocal, right? So y prime will be 2 to the x times ln 2, and the negative 5 just goes away. We want that to equal 3. So 2 to the x equals 3 over ln 2. And if we're careful, we could store that in our calculator. So 3, let's turn it on, clear, clear, 3 over ln 2. So we get 4.308. So let me store that, say as alpha a. So 4.328. So x is going to be the log base 2 of 4.328. So alpha window, option 5, base 2, alpha a. It's good practice to store stuff, because on the AP they do ask you around the 3 decimal places, and your answer is going to have to be pretty accurate. So you don't want to take rounds in all these intermediary steps and then realize you have the wrong answer. So you do want to make a good habit of storing stuff. So x is 2.114. So y will be negative 1/3 times 2.114 plus 2. We could store again, or we could just take the most previous answer. So negative 1 divided by 3. And actually, just to be a little OCD with the parentheses, let's just clear it. Parentheses, negative 1 divided by 3 times the most previous answer plus 2. So we get, oh, I must have done something wrong here. Hold on. Oh, darn it. I'm not supposed to plug into that equation. Shoot. Okay, let's redo this. Hopefully you see what I did wrong. I'm supposed to plug into y equals 2 to x minus 5. I think I'm going to think about the Niners inning. Sorry about that. I'm just a little distracted. Okay, 2.113. Okay, so 2 raised to that power minus 5. There we go. Negative 0.672. My bad. So the point where we get wind up getting a tangent line that's perpendicular to y equals negative 1/3 plus x plus 2 is right there. Okay, so this concludes the video, and I'll see you guys later. Goodbye.